Hello, everybody, and welcome to the AutoCall Fire Detection Academy's webcast series. This is a continuation of a new series of webcasts that's designed to deepen your understanding of some key features and technologies we have within the AutoCall product line, and to deliver a deeper set of knowledge and understanding than you would get out of the normal launch webcast. This launch webcast series are designed to bring awareness of the product and to help you understand the features, benefits, and applications. But we recognize that once you really get into the product and start selling it, there are other questions that usually arise about how to do this, can I do that, is this available, is that available? What applications can I really do with the product once we start beginning to apply it? So this session is to serve as a bridge between the launch presentations, which are at about the 20,000 foot level, and coming to a full-blown multi-day class in a JCI Fire Detection Learning Center. My name is Brian Shifley, and I am on the JCI North American Learning and Development Team for Global Fire Protection Products at Johnson Controls. I'm based out of Westminster, Massachusetts, and I lead a team of trainers that are responsible to deliver fire detection training, technical training, to you or your technicians, either virtually or instructor-led in one of our classrooms. And today, hosting the content for you will be Ed Archikowski, who is a highly experienced senior sales technical support specialist on the Global Products Technical Services team. Ed has many years of experience with our product lines in both the field and in engineering. Ed is a technical sales and subject matter expert in the AutoCall product line and will cover a Vesda net integration in the ES panel programmer for us as well today. I'm excited to have Ed here as the expert to present this material, demonstrate the programming, and to answer your questions at the end of the presentation. And please feel free to bring any questions you have about the technology, integration, and how all this fits together to Ed. A couple of housekeeping items before we get started. Everybody in this session will be on mute. The microphones are live, so if you unmute yourself and talk, you'll be heard by all the participants. And so we'll have you on mute to eliminate any background noise that may happen. The session is also being recorded. So if you have any concerns about your privacy or don't want to be recorded during this session, which will be published later to autocall.com in the product launch webinar section, I'd recommend that you drop off the call now. Also, in terms of questions, what we're going to do is hold the questions until the end of the session where we'll open the floor for Q&A. You can ask questions verbally using the microphone, simply by unmuting yourself, or you can type questions at any time via the chat interface here on Teams. Everyone will see the questions and they too will become part of the recorded session. So with that, I hope that you enjoy the session and I encourage you to ask questions and participate at the end of Ed's presentation. So at this time, I'd like to have it send it over to Ed. Take it away.
Good afternoon, everyone. As Brian has said, we're going to be talking about how we interface Vesda net devices with the 4100 ES and the 4010 ES. What we're able to do is take devices off of an entire Vesda net configuration, specifically the input devices, and bring their smoke obscuration levels, airflow information, detector head statuses and sensitivity information over to our main fire alarm panels. The panels it is compatible with, the interface, is the 4100 ES and 4010 ES. This interface is not compatible with the 4007 ES. If you have a VesdaNet configuration with the older style units that Extralis has just actually discontinued, mixed with the new E-Series devices, everything is fully compatible on the communication network. All the information can actually be brought over to the panel. With the Vesda units, we're able to bring over the alert, the action, and the fire 1 levels. All of these levels are capable of being used within the 4100 ES or 4010 ES programming to initiate system-based functions such as relay operation for fans or doors, as well as signaling. Currently, we are not able to bring across this communication link the Fire 2 level. That is being investigated by the product management group to see exactly what would need to be changed and what would have to happen for future listings. Currently, for the Fire 2 level to be utilized, an IAM is required to be connected to the relay in the Vesda housing itself. Then that IAM would then be used with its status information in the programming. For the 4100 ES, we're able to have 30 HLI interface assemblies per panel. So if we have an existing VesdaNet configuration with 120 Vesda units in the field, it can be broken up into 4 groups of 30 devices, which we'll get into in a minute, and each one of those groups can be brought into the panel. The 4010 ES only allows for a single interface. Each interface internally uses 120 addresses. Each Vesda unit assumes 4 addresses, so that gives us our 30 devices per interface. There we go. The main interface consists of 2 parts. The first part is the actual gateway that is the HLI unit and is normally mounted in an external 19-inch custom box next to the fire alarm panel. This provides our interface with the VesdaNet communication network. It also provides us with an RS-232 link to an internal module mounted in the fire alarm panel. The entire linkage is supervised for communications. If there is a break on the VesdaNet or any of the units go missing, that is reported. If we lose the linkage between the RS-232 card within the system and the actual gateway, we also receive a communication issue. So it is fairly easy to troubleshoot which section of our gate link is actually in trouble. At this point, what we're going to do is we're going to actually go to the programmer and we are going to cover exactly how we add the hardware both in programming and do the actual activation programming. When you go into the programmer, you come up to your default screen where your typical main system job information is entered. You also have your system options page where all of your standard date, time formats, all of that primary system operation information is contained. The first thing that you have to do when you're adding your Vesda interface is it's going to actually sit in one of your bays of the system. So this card has already been added in this example, but it is located in the interface section of the modules, and all you have to do is select it and drag it to the associated bay where you want it physically located. Currently in this job, I have unused lower addresses. So what I am getting is a message asking me if I want to use one of those lower addresses, which would be an insert operation, or if I wish to append this to the end of my group of addresses. I normally choose an append operation just in case in the future I want to actually add something or shift something around. What we're going to do is go back to the card I had originally installed, and we're going to look at how we actually add our devices. So what we are doing is we are actually using 3 point types when we add a device. These are older style system designators, but are fully compatible with all of the last series as well as the E-series devices. So the VE70D would be used with one of the E-series devices, the Plus, where all 4 pipes actually report as a single zone. Obviously, the scan style operation is used for any of those units where each one of the pipes reports individually. The VMIN is used with any of the compact units. And again, that pipe reports as a single zone. When a unit is to be added, all of the addressing is done in groups of 4, as I had mentioned. What we want to do is we want to select a device type that is appropriate for the device that's going to be at that location. So when I go to enter it, I have 2 choices for the point type, which will actually affect how the device operates within the system itself. If we leave it as the default, which is an S3 smoke, no further programming is required in the system. The drawback is that using an S3 smoke provides an alarm condition for each level of activation. So an alert, an action will generate a fire condition as well as a fire 1. To avoid this style operation, we need to select an S3 utility point. What this does is this takes these points out of standard system control and requires that we write a series of equations for what we want to do with them. Once we've determined how we want to set it up and we click apply, we, for this style unit, will consume all 4 of those addresses, 1 address for each pipe. As can be seen, for either the plus or a compact unit, those same 4 addresses for each unit are consumed. So if we have unused locations, they are shown as unused. If we have within a unit a section that is unused, a scanner can actually have only 2 pipes. Those other 2 addresses are still consumed by that unit. When we have Vesda units shipped initially, they are shipped configured with an internal zone designation of 0. This designates the Vesda unit as a standalone unit. It will not communicate on the Vesda net. We need to set a zone number in each unit so that it corresponds to our addressing in our interface card. In this scenario, zone 1 set into a Vesda unit would correspond to device address number 1 through device address number 4. Vesda unit set as a zone 2 unit would then correspond to addresses 5 through 8. This then proceeds until all 30 devices are actually assigned, if there are that many. This is the main thing that we normally see with technicians in the field calling in, where either a device is not reporting at all, they have not changed it from the default zone 0 to a zone designation that actually will allow communication with the VesdaNet, the gateway, and our RS-232 link. Or they have set it as an incorrect zone number in relation to the programming here on the interface card. The next step normally, once we have assigned all of our devices to the card, is to actually configure a series of pseudo points, here we go, that correspond to each of our devices and to each of our levels that we want to enunciate. For the first unit, we had a single pipe configuration. So there are 3 pseudo points, 1 for alert, 1 for action, and 1 for alarm. These points can be defined as being a trouble, a supervisory, a fire, a priority 2, or even a utility point. The advantage of a utility point is, depending on the facility's requirements, a utility does not need to be acknowledged, but is still logged in the history log as having occurred. So if we have an alert condition happen, that is logged. The facility people do not have to do anything with the panel. Most facilities are using a Vesda system because they want that early response. So assigning an alert as a trouble condition or even as a priority 2 condition on the system forces the facility people to respond and to actually pay attention, acknowledge the conditions, which prompts an investigation. For the second unit that we had added, this was a unit that was a scan capable unit. So it was monitoring all 4 pipes if configured that way. In this example, I have actually configured pseudo points for the computer room for an area A, B, C, and D. Each one of these would correspond to one of the pipes. Not all of the pipes would need to be used. So in this situation, I have configured all of the pseudo points, but as we'll see in a minute, I have not set up all of the programming for them. Depending on the size of the facility and what future modifications may be made, it's always advisable to set up all of the associated points for each unit, just in case in the future they do decide to expand the system operation and use those additional pipes. This will keep all of that unit's pseudo points together in a group. In the custom control programming, what we do is for each one of our Vesda units, we are able to program the alert, action, and alarm. It starts with an equation line that defines what the status level is. So a status level 1 corresponds to an alert. We're going to see that an action is a level 2 and alarm is a level 3. So we define which one of the units we are looking at by its address. And then on the output side, we first track on the pseudo associated with that device and that level, and any other operations that we may want to have occur. In this scenario, all I'm doing is tracking on the digital pseudo, so the system enunciates that there is a condition happening in that area. For the action level, it's the same address, the M2-1. I am now setting it so that anything that is equal or greater than a level 2 condition, the action level, is not only going to track on a pseudo now set at a supervisory level, but it's also going to hold on a signal designated as a room warning device. This can be set as a relay, as I have set up in one of the other examples, or it can be a series of signals. So this is something that is determined by the site requirements. Again, this is being held on. It is defined as a generic signal point type. So in this scenario, the programming has complete control over this signal. So in one of the last steps, what we are going to need to do is provide a means of turning this signal off either on a silence or a reset. When we go to the alarm level, what we are now doing is, again, we are the same device. We are at a level 3. We are tracking on a fire condition in the panel. We are now also holding on a second signal that is indicating an alarm. One thing at this point that I am not doing is I am not turning off that other signal. As I said, that signal is not under a default system control. It is under a manual control situation. So if I wanted that previous signal to turn off and only this signal to be turned on, I would need to add a line that basically is then going to hold the point. I am going to want to designate it as off. The priorities I am not going to change. And what I am then going to do is I am then going to bring up the device. And because all of the devices first show up, I am going to filter it down to only my signal devices. So once I do this, I can find my generator room warning signal very easily. I select it. I say, okay. I finish it. Now, in this equation, I am tracking on my pseudo for a fire condition on the panel. I'm holding off that previous signal, and I am now holding on my alarm signal for that specific area. In some applications, the alert, the action signal has been just a strobe. So depending on the site requirements, you may need to change from one signal style to another, or you may need to change how you are notifying that area. All of that can be done through programming. In the other section of the facility, the computer room example, I'm going to jump right to the alarm level. I am using actually a relay as my output. Again, a panel-based relay, a addressable field relay can be used in the output equations. Any of our programming capable devices for an output are capable of actually being designated as part of that output equation. Now, what we need to do as one of the last steps is, as I said, we need to actually make sure that those signals turn off when we do a silence or a reset. The system actually has a series of lists that are predefined that we're able to use in controlling these devices. So we have the ability of turning control points off either on a system reset or on a system silence. We also have the capability of turning control points on, as you can see from list 70, on a generic fire alarm itself. The easiest way to actually add points to a list, and normally control these signals would be added on a silence, is you want to be able to tag the points. Again, I want to be able to find my signals. And whatever signals I then want to ensure are off on silence, I make sure that I have selected them. Let me get down. And I say, okay. The list now shows me that there are 4 circuits or 4 things associated with that list and the control for it. So what we're doing is we're turning things on in the custom control. We can actually, again, turn them off through this same control, or we can let the system take care of it. Again, this all depends on the site requirements and how they require the site notification to be handled. We are able to configure the system to meet, so far, all conditions that I've seen on any job. I don't think we've met one yet where we weren't able to meet the signaling requirements. On a priority 2, if we were to actually use that status for an alert, the priority 2 condition can be reset on the panel separately from fire alarm conditions. So again, depending on site requirements, they are able to configure it so that it would activate a priority 2 pseudo point. But the priority pseudo point needs a separate reset function written that is toggled from the front panel from a separate button than the reset, which is a standard fire alarm reset. The functions can be combined, but on some facility sites, they want that secondary indication so that they know exactly what is happening with any of their different devices. This pretty much basically covers the standard and the basic programming and addition of the card and setting up the basic equations. One thing that we are able to do, and I'm going to go back to this alarm level here, is we are able to highlight the equations, we're able to actually copy those equations, and we're actually able to paste them into a Word document. What this does is it provides two things. One, it provides a record, but it also provides the ability to change the equations and the different levels. Now, along with being able to copy this and paste it into a Word doc, what we are also able to do is we're able to actually start another equation, and we use add equation, and I'm just going to call this test here. And what that allows me to do is highlight everything that's there. Let me redo that. Let me highlight this again, copy it, and paste it in. This allows me to automatically start my next equation for an alert level. So at this point, I would need to go in, I would need to redefine the actual device that I am using, and I would need to redefine my digital pseudo point so that the input and the output both correspond with each other. For record keeping, another thing that we are able to do is the entire program block can actually be exported for record keeping. And when this is done, it comes out as a report that has all of the equations and all of the information into a single document. So this can be used for record keeping, it can be used for troubleshooting, it can be left on site with the customer so that they have an understanding along with an I/O matrix of exactly what's happening with their system. It also gives future technicians who may not have access to the programmer an idea of what they may be looking at for troubleshooting requirements. And I believe at this point, Brian is about to ask, do we have any questions? I know one question came in about, 120. Do all 120 device addresses get consumed even if not all detectors are assigned? Only the number of addresses corresponding to the devices actually get consumed. The other addresses on that interface card are not usable for other system devices. Those are defined as only Vesda. You would need, if you were looking to add pull stations, smoke sensors, or monitor modules, those would be added on the IDNet modules. Another question I see we add, as I'm jumping on Brian's role here, is no, it does not matter what bay the module gets dragged into. Normally what you're doing is you have already configured this system. It has gone through the order process. Someone in the office has done the configuration, sent that configuration through applications engineering. It has been sent to the manufacturing facility, and it has been assembled that way. So what you really want to do is you want to place your modules where it is expected manufacturing is actually going to be configuring them when they assemble this custom configuration. Another thing is when you are doing the panel configuration, the tool that does this actually generates a system hardware default program that will actually have all of your modules already laid out exactly where they should be. So the procedure I showed of dragging and dropping in that scenario would be if you don't have that file and you're making changes or additions, but you should be able to start with a default file that represents exactly the same configuration that the manufacturing facility is going to assemble the hardware to. let's see, are there default pseudo points associated with each detector? No. Basically, what I was doing in the pseudo point area, and let me scroll back to it, in the range I was working in is the beginning of the user section of pseudos. These are generated as required. So when I first did this, I had already entered my devices. I knew what names I had assigned to them. I then came here and then I assigned these pseudo points to reflect the information for each one of the Vesda units. Trevor, I'm not sure if I understand your question of can it be... Okay, I'm going to take a wild guess. Yes, you can edit it in Notepad or Word. You can do a find and replace, which would sort of take care of the manual operation I was describing. So yes, you could do that and then actually paste the equations back in for each one of your operations. I hope that's what you were asking. Okay, the other part of your last question was the HLI does not actually live in a bay. The HLI itself is an Extralis module that sits on the Vesda net and provides a gateway. It also provides a programming socket and a display module. So from that one unit, you can pull up information on all of the Vesda devices, and you are able to actually use the programming through the standard display functions. It provides a Vesda net socket where if you have the proper software loaded on your laptop, you can actually plug into the Vesda net, you can link into each Vesda unit, and you can actually, with their software, do the configuration for each Vesda unit. This, from experience, I have found is dramatically easier than using the display module and trying to remember which section of the menu you actually need to go into. We have had one or two enterprising offices that have taken the HLI 19-inch back box and screwed it into an unused fire alarm bay, and it basically hides behind the door trim. That can be done, or it can be mounted right next to the panel. Mounting it next to the panel gives the customer some visibility as to exactly what is happening to the entire Vesda net portion of the system from the display unit.
Very good. Thank you, Ed. If there are any questions from the floor, please go ahead and unmute your microphone and go ahead and ask your question.
Hey, Ed, since I got you, this is Trevor again. Long-time listener, first-time caller.
And what can we help you with today, Trevor?
So I was under the impression that there was a compatibility issue with using like the 500 range of pseudo points. We did a site integration with an HLI where we had to use in the 700 range, and we had to do like 700, 701, 702, or maybe it was 701 through 703, and then we had to skip to like 721, 722, 723, and we had these areas with large gaps between each one of the hardware points, and we had to associate them only with those ranges of pseudo points, because when we tried to add them in a block like you have demonstrated here, the system didn't work. It didn't communicate across them. Is that something that was just I'm thinking of something different, or is that something that's been resolved?
I would love to see that program, but it is not an issue that I know of. At one point in one of the versions of the special RS-232 software, we did have an issue where certain conditions were not being passed across correctly under certain conditions, situations. That has been corrected. That version of software should not ever be seen by anyone in the AutoCall sales channel, because that was actually corrected before we rolled out the AutoCall line.
You know what? Yeah, this was on a simplex panel, so
Okay.
It could have been. So yeah, I'll send you that program if you want to look at it, but that could very well be the issue.
Yep, that would be interesting to see.
Okay.
Thank you very much, Trevor. Are there any other questions from the field? Please go ahead and unmute your microphone, and please go ahead. We'll check the chat here, see if there's anything new, and there is not. Any final questions for Mr. Ed? No, sounds like there isn't. So Ed, I'd like to thank you for participating today. Your time is very valuable, as the customers that are on the line. Your time is valuable as well. We do appreciate you taking the time to come and learn some more about the great products that we have and how to apply them. So that will conclude today's session, and we will look forward to seeing you at our next session. And so stay tuned for more invitations coming your way. So thank you very much, and have a great rest of your day.
Nice job, guys. Thank you.